So Teresa, I'll leave the chat open too. So if there's anything you want to let me know while the presentation's going on, just you could type it. You could send me a message direct through there, like if you can't hear me or something.
Okay. Yeah, I see that we've got some people joining us already. So welcome everyone to Larkspur Library. We're going to get started in just a few minutes. Oh, fantastic. Thank you for letting me know that you could hear us. That helps. Appreciate that.
Thanks for joining, Evan. I recognize your name from Redwood High School.
A former student of yours.
No, actually, his teacher just sent me an image today that Evan took of something that looked kind of mysterious in the sky, and we think it's the star Sirius.
Oh, cool.
That's my guess, anyway.
Okay, well, welcome everyone. I think we might wait just another minute or so more to give people a chance to join before we get started.
Hey, Nancy, thanks for joining. Hope you're all well, Aaron. Hi to Zoe and Tessa.
That's great. Okay, well, I think we'll go ahead and get started now. Let's see here. Oh, there we are. All right, well, let me introduce our speaker. So, I'm Teresa from Larkspur Library, and just welcome everybody. So glad that you're here today. So happy to have Ron Rosano back. He has done many presentations for us over the years, and I'm really looking forward to today's talk, Apollo, on the Moon with Apollo. Ron has been a NASA Solar System Ambassador since 2008, but he was inspired to take an interest in NASA and all things space from the time he was a very young boy, and the Apollo flight missions were an inspiration for him. So I think this will be a really a talk close to his heart. I know that you'll enjoy today's talk. We're going to take questions. We'll stop at certain points and take questions. If you can enter any questions that you have in the question and answer box, and then I will relay those to Ron. So thank you, Ron, and go ahead and take it away.
Great. Hey, everyone. Thanks so much for joining. Glad to share excitement about the Apollo moon landings. You know, seeing the moon in the sky is still amazing to me to think that, oh yeah, we went there. So I'm going to jump right in. I'll go for, I think we're planning about 45 minutes in total. And I've got slides for about 25 minutes or so of that. So we'll stop maybe halfway and answer some questions. Love to have some, dialogue and hear what you're thinking. So, here's a footprint from the moon. And because there's no atmosphere there, that footprint is still there exactly like that right now and will be for thousands of years. I'm going to go through 5 parts here, just a quick historical background, then talk to the early missions, focus a little bit on Apollo 11, then the 5 later missions that land on the moon, and then look a little bit to the future. So back in the 60s when Apollo was just coming together, there was a lot of turmoil in the United States, around the world, Vietnam War, assassinations, and 2 things that I think of now that, back then we thought were just permanent for everyone. Everyone had a newspaper delivered to their door and everyone had a landline, but that's not so much true anymore. And of course, back then was the Cold War, United States and Russia, democracy and communism. And a lot of the technology that Apollo used comes from ballistic missiles and missile technology. And really the first flights were really just modified ICBM, intercontinental ballistic missiles with people on top. So there were many missions that led up to the very first landing of Apollo 11 in July of 1969. That all started in 1961 with Yuri Gagarin from Russia, orbiting the Earth 1 time and landing back in Russia. Found out recently that actually ended up to be a very dangerous mission that didn't go exactly as planned, and he almost didn't survive. Alan Shepard from the US just a few weeks later flew a suborbital flight, so just up and back down, kind of downrange, didn't actually orbit the Earth. And I think had the US known that Russia was, or the Soviet Union was close to flying, that they might have actually flown Shepard earlier, because I think it sounds like they really had the potential to do that. In an amazing leap, and this is just May 6th to May 21st, 2 weeks later, after Shepard's flight, John F. Kennedy comes into Congress and say, okay, he believes the nation should commit itself to landing on the moon by the end of the decade, thus setting a timeline that really rallied the country to try and achieve it, especially after he was killed in 1963. From the 2 years of May 61 to May 1963, there's the 6 flights in the Mercury program, the initial program. The 7 Mercury astronauts became household names, followed by Life magazine, very prominent. Following that, there was the second program part of Apollo called Gemini, with 2 astronauts. This particular photo you see there is Neil Armstrong down at the bottom, first man on the moon, and Dave Scott, his co-pilot, who walked on the moon on Apollo 15. After the Gemini program, Apollo moved on to Apollo 1, which tragically ended with a fire in the spacecraft in a test on the launch pad in January 1967. And that was an enormous setback for the program. No one ever expected that astronauts could be killed in a test of the program, and really came as a shock to all the people involved. There was a lot of work to redesign the spacecraft and prevent that kind of thing from happening again. They changed the atmosphere of the spacecraft. Instead of using 100% oxygen, which caught fire easily in Apollo 1, they changed to an oxygen-nitrogen mix, and did a lot of other modifications. And then continued on with Apollo 7. Their intention was to fly a lunar module on Apollo 8, but the lunar module wasn't ready. And in a very bold decision by NASA administrators, they decided to, well, let's just send the spacecraft to the moon without a lunar module and prove out that part of the process and of the mission. So in an epic flight in December 1968, Jim Lovell, Frank Borman, and Bill Anders orbited the moon. And these were the first humans to leave near Earth orbit and to venture as far as the moon. And that that picture you see there became one of the most famous pictures ever taken, an icon of the Earth movement, and a beginning of understanding and visualizing that, oh wait, the Earth is really just, floating out there in space, and we're all on this planet together. Early in 1969, Apollo 10 did a dress rehearsal going to the moon with 3 astronauts, flew the lunar module close to the lunar surface, but didn't land, and just a test of the systems and communications and all kinds of other things. So that brings us right up to Apollo 11 in July 1969 and the first lunar landing. So this was an 8-day mission and the third to leave Earth orbit. There's the astronauts that were chosen to fly, household names, I'm sure most for all. Aldrin, Armstrong, and Collins there left to right. They didn't actually find out that they were going to be the crew until January 1969, just 6 months before they flew. And there's their formal portrait. So in those 6 months of training, it was a very intense period of time. So many things to do. One of the important things to do on the moon was one of the objectives was to find out where the moon came from and how it formed, how it relates to how the Earth formed. And a lot of that relates to geology and sampling rocks. So there was a lot of instruction about, how to look at rocks and how to take rock samples from a site. Learning how to develop the tools, getting used to the suits. The suits themselves are actually a spacecraft, and they're pressurized. They're very difficult to work with. It's like a tight-fitting balloon that's blown up with air pressure around you, and it has a natural place where it sits. But if you're going to move against where it naturally sits, you're going to require a lot of force. So one of the things they found out is that it was very physically exhausting to walk around in the suit. And one thing you notice here is Armstrong. They're practicing the distance that he'll have to jump from the ladder down to the landing pad. That was actually a dish about 4 or 5 feet in diameter that he stepped onto first before he stepped on the moon. A little explosion there on the left is a accident that happened in one of the training simulators that Armstrong was flying that performed and flew exactly like the lunar module, but had an accident and had a malfunction. And within a split second of things going really badly, Armstrong ejected and parachuted about 150 feet back to Earth. They were also set back by Apollo 10, getting the priority in the simulators, and of course, a lot of mental pressure. Once they did get in the simulators, you can see here what it looked like. So Armstrong on the left, Aldrin on the right, in a ground simulator. All the displays there in front of them. And you could see above Aldrin's head a small window with markings on it. So they would use etchings into the glass to help them determine, as they were flying, distances and angles of things that they were docking with. So here's a little bit about the flight path to the moon. And once they lift off from Earth, they go into Earth orbit at about 17,000 miles an hour. In order to leave Earth orbit, they have to accelerate, and they fire an engine on the third stage of the rocket for about 6 minutes to accelerate them up to 25,000 miles an hour. But what's fascinating about that is that gravity is pulling against them the entire time. So while you hear terms like zero gravity or zero G, there's really not any such thing as zero gravity. Gravity exists throughout space. It holds the space station in orbit around the Earth. Gravity from the Earth holds the moon in orbit around the Earth. So as they're on their way to the moon, gravity is holding them down in a way that's similar to throwing a ball up in the air and having gravity stop it at a certain point and pull it back down to you. Well, gravity's pulling back on all the Apollo missions the same way, so that over the course of 3 days, they're slowing down from 25,000 to 20,000 to 15 to 10,000 to 5,000 miles an hour when they go to the moon. So it's very much like rolling a ball up a very steep hill with just enough energy so that it gets to the top of the hill and just kind of goes over the other side. And you can imagine the difficulty of the calculations of how to aim that and how to get the spacecraft on that precise path so that when it's 200,000 miles away, it's right at a pinpoint spot in space where they want it to be, and right where the moon is. Here's Aldrin inside the lunar module. On their way out to the moon, they did a systems check, turned the power on, checked some of the systems, and you can see the two triangular windows that they each look out while they're flying. There's the lunar module. After it had separated from the command module, they use the lunar module is made just to fly in space. You can see the ladder that Armstrong and Aldrin came down later, and the square hatch right above the ladder that they use for entering and exit the module. You also see 3 probes there. 3 of the legs had sensor probes on the bottom, about 5 feet long, so that as the lunar module got closer to the lunar surface, there'd be a light that came on, a contact light inside the LEM, lunar module, that would tell them that, okay, you're right above the surface. And what they needed to do right then is cut the engine off, because if they had flown the engine all the way down, there was a chance of material from the lunar surface damaging the engine or having some other problem. So they actually cut the engine off when they're above the ground and just kind of drifted right back down. So here's some video from the actual landing and the final approach. And I'm going to skim ahead a little bit here, and you can see a view from orbit and on the right, and on the left from a camera mounted in Aldrin's window. So as they're approaching, they're passing these craters, and Armstrong found that their targeting system was sending them towards a crater that was too big and too dangerous to land in. So what he had to do was fly the lunar module like a helicopter horizontally to get beyond that crater and settle in just beyond it. And I'm going to pick up the audio here as they get a little closer, and you'll hear a voice call out 30 seconds. And that's Charlie Duke, the capsule communicator, back in Houston, saying they have 30 seconds of fuel left. And you'll notice that they don't land right away at 30 seconds, that they land a little bit after that. So they really landed on almost a dry tank.
Down 2.5. Forward. Forward. That's 40 feet, down 2.5.
And that's Aldrin calling out, parameters to Aldrin while Aldrin was, calling out to Armstrong while Armstrong was just concentrating on flying.
Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 20. Down a half. 30 seconds. Forward. Just. Good. Okay. Contact light. Okay, engine stop. APA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Charlie Duke's from South Carolina, and you could hear his little southern accent there. I'm going to show next some videos of Armstrong coming down and taking his first step.
Okay, can you pull the door?
And they had a camera mounted also up in the window, and you can see him coming down the ladder. And He talks a little bit about the lunar surface.
1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Famous words. Here's a photo that Armstrong shot of Aldrin on the surface. It's one of the most famous pictures to come out of the program and maybe ever taken. They only had one camera on the surface, and they didn't really have a program for who's going to take pictures of what. They had a certain group of pictures that they wanted to take, but kind of interestingly, there was not any instruction for, okay, Neil, you take a picture of Buzz. Buzz, you take a picture of Neil. Raise your helmet so we can see your faces. No, they were very busy in the 2 hours they were on the surface. And you'll see a few things of interest here. Reflected in Aldrin's helmet, you could see Neil Armstrong, the figure of Armstrong, taking the picture. And that's actually one of the only pictures of Armstrong on the surface. Aldrin didn't take any pictures of Armstrong while they were outside. You can also see some dust on Aldrin's knees. Those are from when he was coming down the ladder, and his knees brushed against the ladder rungs that Armstrong had already rubbed off some moon dust onto. And then right at the bottom, you see one of the probes sticking out of the landing pad. So those are the probes that you saw in the earlier picture. And, they got bent over, and you get an idea of the soft powderiness of the lunar surface. So there's a close-up of Neil, and yes, not a great picture of him. Here's one picture that they found not that long ago, just a few years ago. Someone went very carefully through some of the film and found this picture of Neil Armstrong with his visor up. So that's really the only image you have where you could see Armstrong's face while he was out on the surface. Of course, when he got back, you could see the relief and joy in his eyes. This is after the moonwalk and after they were secure inside the lunar module. And Armstrong talked about the landing as really the most difficult part. It had never been done before. There were a lot of unknowns. It was the part of the mission where they thought it was something could go wrong, and it was the most dangerous part. And once they got back and did their moonwalk, there was an enormous relief, because really from there, there's still some very important things that need to go right. Lifting off from the moon and firing an engine to get out of lunar orbit back to Earth, but they know we're a lot closer to home free at that point. And this is the view as the top half of the lunar module, the ascent section, approached Mike Collins, who was alone in the command module orbiting the moon. Beautiful shot by Collins with the ascent stage and moon and Earthrise right behind it. They landed on July 4th, 1969, and spent 2 weeks in quarantine, sealed in a trailer that was flown from Hawaii to Houston. And they're wearing these biological isolation garments, kind of almost like a hazmat suit, because there was no way to be certain that there could have been some kind of unknown microbe or something that could affect the health of the astronauts, and they didn't want to expose the rest of the people on Earth to that if there was something really dangerous that they didn't know about. Luckily, it turns out there wasn't. So here's a little breakdown on how they spent their time on Apollo 11. So obviously most of it is back and forth to the moon, and the actual walking on the moon part was just about 2 hours. So all the subsequent missions built on that. And every mission through Apollo spent more time on the moon, brought back more rocks, and finished with Apollo 17. Here's a diagram that I thought was interesting. In the yellow there is a map of, to scale, the distance that Aldrin and Armstrong traveled while they were on the lunar surface. And the little cross-like shape there is the Lunar Module. And you could see by the scale of 50 meters that that's about the farthest distance they went from their landing craft. And this is superimposed on the aircraft carrier Intrepid, which is docked in the Hudson River off the island of Manhattan. So if you're in Manhattan, you can visit the Intrepid Air and Space Museum. They have space exhibits, they have aircraft exhibits. You might notice a Concorde a supersonic jet there in the top left. So I'm going to come back to this image later and we'll get an idea of how far the Apollo 17 astronauts traveled in relation to how far Apollo 11 traveled. After they returned, the three astronauts were sent on a whirlwind giant leap tour to celebrate the accomplishments, and they visited 27 cities in 39 days, and what they described was an exhausting trip, and visited heads of state in all the countries, the Pope, Queen of England, Emperor of Japan. And it really got a sense at this point of how important it was for the country to share with the world that, yes, hey, we did this. And then some of the astronauts too also talk about, yeah, you know, people say, oh, you went to the moon, meaning you, the astronauts, went to the moon, and they more often, and very often said, we went to the moon, thinking as humanity made the achievement all as one. So I'm going to pause now, and maybe we could take some questions. How does that sound? And let me look at the Q&A real quick. I don't have any open questions. Yeah.
If you have any questions, go ahead and enter them in the Q&A box. Okay, well, we'll take questions too, I think, after Ron's finished with his presentation. So you'll have another opportunity.
Cool, great.
All right, well, if there aren't any questions, I guess we can go ahead.
All right, great. Well, thanks. And let's continue on with the later Apollo missions. There's been a lot of interesting things that happened there. Apollo 12, Pete, Conrad, Gordon, and Bean was the next crew up. They landed in November 1969, and so not only was Kennedy's goal accomplished, but it was accomplished twice. And they set a tradition here with the commander of each of the subsequent missions being a veteran astronaut, someone who'd flown in space before, and the Lunar Module pilot, the second person to accompany the commander on the moon, was a rookie pilot who had never been in space before. And in this case, it was Alan Bean. You can see him there smiling on the right. One of the important things they wanted to do with Apollo 12 was to prove that they could land precisely. And Apollo 11 landed much farther away than its target, but it was very important for further missions to land close to where they intended to be. And Apollo 12 proved that very well. They landed right on their kind of a pinpoint landing and were able to visit this Surveyor spacecraft that had landed on the moon a few years earlier. This is one of the better images from Apollo 12, and you can notice this is of Alan Bean, and you notice the camera mounted on his chest, but also you could see on his left arm the watch strung up way close to his elbow, and then the little cuff checklists. All Apollo astronauts used a checklist on their wrists to keep track of things and remember the things they had to do, when they're at certain locations. So Conrad Bean were a very interesting pair. Neil Armstrong was very calculated, thoughtful, quiet. Conrad, the commander of 12, was very much the opposite. He's very gregarious, very outgoing. And he tells a story of meeting a journalist prior to his flight, and the journalist saying, "Gee, that was nice of what NASA told Neil Armstrong to say when he got on the surface, the one small step." And Conrad said, no, we get to say whatever we want. And they said, and the journalist was like, "No, I don't believe that." And Conrad's like, "I'll bet you $500. And this is what I'm going to say. That was a small step. That might have been a small step for Neil, but it's a big step for a little guy like me." Conrad was a few inches shorter. And sure enough, when Conrad came down the ladder, that's exactly what he said. Alan Bean, you could see the kindness in his eyes here. He spent most of the rest of his life developing skills as an artist, and is very well appreciated and a well-regarded artist. And that's a departure from someone who came up, spent their career as military pilots. And you can really get a sense of him as a person. If you ever look up interviews or anything, you can see pictures of him in his art studio. Apollo 13, most people know, yes, that was had a very tragic. Well, it had a very difficult situation. On their way out to the moon, an oxygen tank blew up and crippled the command module. And as you may have seen in the movie with Tom Hanks, they underwent some very difficult circumstances, overcoming that and getting back from the moon. So what they did is they had, because they were out of electrical power, they had to shut off the power in the command module and live for 5 days in the lunar module with 3 people, which was really only meant to last 2 people for 3 days. So they had to turn off all the heat. The temperatures got down to the 40s, and they became very, very close to not making it back. And there they are on the aircraft carrier after landing, and you can see a picture of the service module with the entire side of it blown off from that explosion, and underwent some very difficult conditions. Apollo 14 continued on after a lot of review in 1971. They brought to assist with them moving around on the moon. They brought a cart. So Edgar Mitchell and Alan Shepard landed on the moon. Stuart Roosa stayed in orbit. And one thing you'll notice here about their lunar modules, you could see the probes there sticking out, and all the antennas on the top. Communication was very important because they wanted to be in constant contact with the Earth. So they spent a lot of time managing their communications. There you can see a picture of the cart that Mitchell and Shepard carried around to help them carry tools and bring samples back, and had 2 wheels, and you picked it up and rolled it along behind you, and that actually turned out to be a not very helpful way. It turned out to be heavy and more cumbersome than they expected. And on the right, you can see Mitchell using a map. What the difficulty they experienced was that distances became very hard to judge, and they were supposed to, their aim was to reach this rim of a crater that was nearby. And they kept thinking, oh, it must be right there. And oh, it must be right there, must be right there. And they finally gave up and didn't make it to the crater, and fell a little short of their geology goals. Mitchell, on the way back, had an epiphany. He had finished all of his lunar pilot duties. So really on the journey back to Earth, he was left to have he had a lot of time to contemplate things. And he had a an idea of seeing the heavens and being part of the heavens and being one with the heavens that no one had really ever experienced before or explained before. And he later went on to found this Institute of Noetic Sciences, not far away. They're based in Petaluma. And this again was like Alan Bean becoming an artist, this career military officer, test pilot, became very involved and admitted his life's ambition to help understand this cognition change that he had of being one with the universe. He realized that all the atoms in our bodies and in the spacecraft all came from stars, and he kind of saw everything existing as one. So Apollo 15 was a big change in the way they operated. Dave Scott was the commander. Jim Irwin was his Lunar Module pilot. While Apollo 14, Shepard and Mitchell didn't succeed so well in geology, Dave Scott embraced the geology and got enough training, the equivalent to an advanced degree in geology. And he accomplished more in terms of the science and understanding of what they were finding on the moon than anyone else. Al Worden in the middle became a lifetime advocate for space education and awareness. And he often came to Novato, to the Novato Space Festival, to talk to people there. And I was fortunate enough to talk to him a few times, and he had just tremendous energy and enthusiasm for the program and for space travel. They landed at a very scenic site next to a rill. It's kind of like a riverbed. Did some sampling from there, really spectacular views. And here's a video of Dave Scott doing a little experiment that he devised about how objects fall in places where there's not any air. So here's Dave Scott.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
So there you go. A hammer and a feather fall at the same rate if you're on the moon. Here's one of the great discoveries in Scott in the Lunar Receiving Lab with one of the oldest rocks that they found on the moon. It was really a breakthrough to find this. Came from a piece of the moon's crust, and his training in geology really helped accomplish that kind of thing. So the last two missions, Apollo 16 and 17, took place in 1972. John Young commanded 17, and there's Charlie Duke, who we heard with his southern accent in the Apollo 11. He was the capsule communicator for 11, and then later walked on the moon with John Young. One of the things they did was test drive this Lunar Rover. And here's a little video of that.
That's all, Mark. That max acceleration? No. Man, you are really bouncing.
Is he on the ground at all? That's 10 kilometers.
Huh? He's got about 2 wheels on the ground. He's a big rooster tail out of all 4 wheels. And as he turns, he skids. The back end breaks loose just like on snow. Come on back, John.
Here's a close-up of the rover, and a lot of interesting things there. The two seats there are facing towards the right. So this is the rear end of the rover, where there's a rack where they carried their all their tools and things. And then if you look right below the rack, just below center of the picture, you can see you're seeing straight through the tire. It's not filled with air because of course there's no air on the moon. They want to have something filled with air. So it's actually a construct of metal and wire that the tires were made out of. One of the reasons that was possible was because the moon's gravity is only 1/6. So if the astronaut weighed 180 pounds on Earth, they'd weigh 30 pounds on the moon. And so it was much easier to construct things like the rover. Here's a fun picture of John Young in a leaping salute. His feet are way off the ground there. And Charlie Duke, in a poignant gesture, left a photo of him and his family on the lunar surface. So Apollo program wrapped up in December 1972. Gene Cernan there seated was commander, and Harrison Jack Schmitt was the Lunar Module pilot. He's there on the left. He was actually substituted there was plans to have Apollo 18 and 19, and they built the hardware, the rockets for those, but then canceled those two missions. And another astronaut that was supposed to go on 17 was removed, and Jack Schmitt got placed on it because he was a professional geologist. And the science community made a very strong case to NASA that, yeah, if we're going to be learning things about the moon, we need somebody who's an expert in geology. Here you can see a little bit of their landing site. The Lunar Reconnaissance Orbiter in the last few years is taking highly detailed images of the Apollo landing sites and many other things on the moon. And these little dark lines are footsteps from the astronauts and from the tires of the rover. And this is just a small part of the area that they traveled. Here's a great picture to finish up with. Here's Gene Cernan holding the flag and the Earth in the background. And another picture of Cernan inside, and you can tell he looks very weary and very dirty there. That's one thing that's going to be needed to be dealt with on future missions, is what to do with all this lunar dust, because it really messes up all the equipment. And here's the map I was mentioning earlier. So there, the top center, you see a little circle with Intrepid, and that's the area of the aircraft carrier that was much larger than the distance that Aldrin and Armstrong traveled. But the orange line here is the three different EVAs, the three different trips over 3 days, one per day, that Cernan and Schmitt took with their Lunar Rover superimposed over a map of Manhattan. And you can get an idea of the greater distances that the later missions were allowed to travel because of the Lunar Rover. So here we are in summary. So the 9 missions with 3 men each, half a dozen landings, and a dozen men walked on the moon. 3 men actually went twice, Lovell, Young, and Cernan. So it's really only 24 people have been beyond Earth orbit and seen the moon from up close like that. And here's something fresh from yesterday's news. As President Biden changed the decorations inside the Oval Office, he added a moon rock. So if any of you ever happen to find yourself in the Oval Office anytime soon, you can see a moon rock brought back by one of the Apollo missions right there in the office. So to finish up, I just wanted to look ahead a little bit. There are plans for future human missions to the moon, and there's also an upcoming era of commercial space travel where people from all over the world can buy a ticket to fly into space. From NASA's funding 2 programs. You might be aware of these. SpaceX has flown twice now and has a space capsule that's docked at the space station. Boeing also, in a separate program, has developed this Starliner capsule. So those 2 are going to be ferrying astronauts from Earth and up into the space station, and all with NASA funding, billions of dollars of NASA funding. Separately from that, we're on the cusp of a new era of suborbital commercial spacecraft. Virgin Galactic and Blue Origin have developed 2 different systems that will take paying customers, passengers, on a very short trip into space and then back down again. And the excitement of having, you know, hundreds and thousands of people seeing the Earth from space is growing. And beyond that, there's two other systems that are also in development and have been really active in the last weeks and months. NASA's building this Space Launch System, the SLS, that you see on the left. And just 5 days ago, they did a test fire of the core stage. So you can see that in the drawing on the left, this is an actual picture on the right of that center stage that has 4 rocket engines attached to it. And they fired all 4 engines in a successful test for the first time just within a week. SpaceX is building this Starship. So this is privately funded by SpaceX. Actually, I'm not sure about that. NASA might have some funding. And just last month, they flew this version of the Starship called serial number 8, their 8th version, up to about 40,000 feet. And their intent is to land it on its rocket side. Unfortunately, it came in a little too fast. They had a little malfunction at the end, and they had what SpaceX calls an RUD, rapid unscheduled disassembly, and an explosion there at the end. That's actually wasn't so bad for them because they proved out so many other parts of the flight. And right now, their serial number 9 is out there on the launch pad at their launch site in Texas, getting ready to go. So that you'll probably see in the news within a few weeks. I'm going to finish with this photo of the Earth from Apollo 17 on their way back from the moon. This is one of the few full Earth photos that we have. You can see Antarctica there at the bottom, the continent of Africa there. And like Apollo 8's Earthrise photo, this has become iconic in awareness of Earth in space. And you had a very large contribution to the start of the whole Earth movement and awareness of the need for preserving our planet. So, you know, of all the benefits that come out of the Apollo program, this was a significant one. And that's all I have for you. So
that was wonderful. Thanks so much, Ron. We do have a couple of questions.
Great. I see them
those.
there. Yeah.
Oh, great. Okay.
So how many American astronauts have there been in space? And how would I sum up the astronauts' reactions to having traveled to space? How did it affect them for the rest of their lives? There have been about 580 people in space in history since 1961. Good comparison for that is that Virgin Galactic, and full disclosure, I've actually have bought a ticket to fly with them. They have about 600 people signed up to fly with them. So they're actually going to be flying more people into space than have ever been flown in history in not too distant future. And then Blue Origin will be adding to that total. And yes, in listening to interviews with astronauts, I got a really strong sense that they were affected deeply by the experience of leaving the planet, leaving the surface, being in orbit, and especially of going to the moon. Like you saw with Alan Bean being an artist and Ed Mitchell pursuing this idea of consciousness with the universe. They were affected in ways that I don't think any of them ever really expected or could predict. So as more people go to space, I think we'll have a lot of really positive influences on the Earth. So let's see, the next question. Are we aware of the location of discarded lunar module upper stages or service modules or third stages of Saturn V's? Yes, a lot of them are tracked. Thanks for that question, Paul. The lunar module upper stages, I think most all crashed into, I'm not sure if they crashed in the moon. They might have been crashed in the moon. I don't think they're orbiting, but I'm not sure exactly. The service modules, I believe, burnt up in Earth in the Earth's atmosphere as they were coming down. The third stages of the Saturn V, at least 2 of those were intentionally impacted on the moon, and that after the command module and lunar modules for the astronaut inside separated from the third stage, which boosted them towards the moon, they remotely controlled those third stages to hit the moon for the purpose of calculating and helping calibrate the seismometers that the earliest moon missions left. So Apollo 11, 12 left seismometers to measure earthquakes on the moon. And by impacting a third stage on the moon, which was something that they knew the exact weight and mass of, they could perform a lot of, they could perform a lot of science on the interior of the moon by knowing how it quakes from being impacted like that. Oh, here's a question, Nancy. Thank you. The image behind me on the wall, that's a Space Shuttle Columbia in these art panels that I found a long time ago, and finally had a wall big enough to place them on. And I see a question from Barbara in the chat. Are there moon rocks now in many different locations for view and study, although mostly only a few limited places? Yeah, that's a great question. The moon rocks, Apollo made the materials, the rocks and the dust that they brought back from the moon available to scientists all over the world. And they sent out samples to, I think, more than 400 different universities and research research institutions around the world. So scientists in other places could examine the rocks and do their own science. And yes, there's some people that question whether we landed on the moon, and that's actually one of the better arguments against that is that, well, hundreds of experts and scientists have seen the moon rocks, and no one ever questioned that no, they're not from the moon. So thanks. But they do keep the majority of them in a lunar laboratory in Houston. And I think there's a subset, a smaller set out somewhere else in the US. NASA does make a sample of a group of samples available for teachers. So if you're a teacher somewhere and you're doing science, you can sign up and go through a questionnaire and a survey and ask NASA to send you the samples, and they'll let you use them in a classroom. Okay.
Okay, that I think.
Questions, but yeah, go ahead.
Yeah, I don't see any other questions. So I want to thank you again for being here. I always learn so much when you do these presentations, and we're hoping to have you back again soon.
Great.
So everybody just keep an eye on our event calendar for the next time Ron will join us. So thanks everybody for being here, and we will be posting a recording of this on YouTube and sending out a link for that later on today. So thanks for joining us, everybody.
Thanks, everybody.
Have a great day. Thank
well.
you so much, Ron. Bye-bye now.
Bye.